Hey, what's up and how's it going? My name is Toby, and in today's video we are going to take a look at semantic segmentation within Unity and its AR plugin Lightship. So semantic segmentation is a quite cool feature that can be used for a multitude of purposes. For example, as we're going to do in today's video, is to let the player interact with actual real-world objects and elements such as the foliage, trees, sky, and for example gather some kind of resources or so. But it could also be used for meshing, so for example to exclude specific semantic channels out of the meshing, so to not have, for example, humans being meshed. Or it can also be used for some kind of occlusion. If you want to make some kind of monster type game where a gigantic monster attacks the city, let's say, then this could be used as a occlusion. Alright, but without any further ado, let's get started. So we're here in a brand new Unity project, and I begin by installing Lightship through the package manager by using the git URL. The URL is of course in the video description, so you can simply find it there. And then after the installation was finished, you can go to build settings, then choose either iOS or Android as you like. And after that, let's go ahead and go to our project settings. And then within the XR plugin management, make sure that Lightship is enabled in all the important tabs. And then in the project validation, let's simply click on Fix All for all our platforms. And then of course, make sure to then get an API key by going to the Lightship website, creating a new account or logging in, then creating a new project, name it as we like, and then just copy the API key, and then in the Unity editor, just paste it in. So then finally, let's create a new XR origin and a new AR session, and let's make sure that the XR origin is at position 0, 0, 0. And then the final thing we can do is to go to our build settings and add open scene. So then if we build to our device, our current scene is going to be used. So next up, let's create a few objects. So let's go into the sample scene, make a new UI and then a raw image like this. And then let's go into the 2D view. Let's click on the canvas, click Shift F. So this is our whole, basically our screen here. And if it doesn't look like that for you, you can simply go into the game view and change the aspect ratio here to something that you like. And then let's click on the raw image, and on this square here, let's click on that and let's hit either Start or Alt on Windows or Mac, and then the Shift key, so that we can stretch the raw image over the whole screen and also reset the pivot to the middle. Then on the canvas, let's go to UI and then let's create a Text Mesh Pro. You might get a message to import some TMP essentials here, so simply click on Import. And then let's also make sure that the text is centered. It already is, just looks a bit weird because of the grid here, but it indeed is in the center. Let's just type something like ground, and then let's set the vertex, so the font color to black. And then let's just align it in center and middle, so it's really well centered. All right, so this is the first thing that we need to do. Now let's create a new folder, and let's call this folder Shaders. And next up, we need to create a new shader. So for that, let's just click on Create, and then Shader, Unlit Shader, and let's call this one Semantic Shader, like this. So let's double click and open it up in our IDE. And so once it has been opened, so this is just the standard unlit shader, we can actually go ahead and delete all of this here. And then what we want to do is copy and paste a new shader. And this code here is in the video description. It's also provided by Niantic for us. And it's a very basic shader, and what it's doing is pretty much aligning. So a bit later on, we'll get the matrix with the potential semantic classes from our semantic segmentation manager. And to actually map those to our screen and to make sure that when we have this red overlay, it will look correct, we will need to do a few calculations. So we need to, for example, calculate the object to the clip position, but we don't need to fully understand how this shader works. We just need to understand what it generally does. All right, so let's just then close this window here and let's go back into our editor. So next up, let's create a new material. So go to Assets, Create Material. Let's call this one Semantic Material. And then let's create a new folder. Let's call this one Materials, and let's drag in the semantic material like this. So then if we click on the material, we can then attach the semantic shader. And now this one is on here, and we can already go ahead and then select a color that we want to be overlaid. So we could, for example, use red and just reduce the alpha value, so the opacity, so that it will not fully occlude the object, but is transparent to a certain degree. Okay, so then let's close this window here. And then next up, let's actually go ahead and add the semantic segmentation manager. So let's create a new game object and call this one semantic segmentation, like this. And let's add the AR semantic segmentation manager here, like that. All right, cool. So we got now a material, we got a shader, and now we need to have a script that combines this with our semantic segmentation manager. So then let's create a new folder and let's call this one scripts, like this. And let's create a new script and let's call this one semantic query, like that. And let's open this one up. So in the script, let's begin with declaring a few variables up here. So first of all, we need a reference to our AR camera manager. Let's call this one camera man. And then let's also create a reference to our semantic segmentation manager, of course. So AR semantic segmentation manager. And let's call this one semantic man. So then we'll need a few more references to our text mesh pro. So of course to our text here. Let's call this one text. Then let's also create a reference to our image, so to our raw image. And this one we'll call image. Oops, like this. And finally, we'll also need a reference to our material. So let's call this one material, like this. And finally, we'll also want to have a string that will hold the kind of semantic class that we'll get. So let's call this one channel. Let's call this one, for example, ground, like that. So then in our onEnable, let's begin by subscribing to the camera manager, and there's a method that's called frame received, so on each frame, basically. And we're gonna simply create a new method, and let's also call this one args and not obj. So anytime a new frame has been received, let's first of all go ahead and say that if from the semantic segmentation manager, if the subsystem is not running, then we of course just want to return like this. So make sure to have this exclamation mark here. And so otherwise, let's begin by creating a new matrix. And so this 4x4 matrix will actually use to transform the output of the semantic segmentation manager. So basically the matrix that has this overlay for all the semantic channels. So in order to transform that so it will fit onto our camera, we'll need these 4x4 matrices. So let's create a new 4x4 matrix and just make it to the identity. So pretty much empty matrix, if you want to say so. And then we'll create a new texture variable. And we're gonna go into the segmentation manager and we're gonna get the semantic channel texture. And we'll put in our channel name. And then we're gonna put in and assign our matrix like this. And so then if we get a texture out, then we're gonna create another matrix, which we're gonna call the camera matrix. And this one is going to be either the display matrix, if there's one, or otherwise the identity matrix, like this. So then for our image, let's go ahead and set our material to the material that we have defined up here. And then we'll also want to set the texture of the material. So this is basically what we just defined by the shader. So now we're setting the attributes of our shader. So we're going to use the semantic texture. Set this one to the texture. And we're also gonna take the semantic matrix and we're gonna set this one to the matrix like this. All right, so then next up, let's delete the start method here and let's gonna continue with the update. First of all, we're gonna define a timer, so float timer, and this is going to be 0.0. And then down here, let's first of all check whether the semantic segmentation manager is actually running. So let's check if the subsystem is running. And if it's not running, basically, and if it's running, then would continue. If not, then we're just going to return. And then we're going to say that if the input and then the get mouse button down, or if we get an input in form of a touch, so input.touch, and we're going to take the length here, and if this is greater than 0, then we want to do something. So for example, we can say then that there's a new variable, we're going to call this the pose, and this is going to be just the input and the mouse position. And we're going to say that if, well, first of all, we need to check whether this position is actually on the screen. So if this is greater than 0 and smaller than the screen width. And then let's also make sure that it's in the y-axis on our screen. So basically in the area that we want to check. So then let's increase our timer here by time.delta time. And let's say that if the timer is bigger than 0.05, so after 0.05 seconds, we want to go ahead and get the name of the, so let's call this one list, and let's gonna get the semantic manager, and let's get channel name at, and we simply can say int, and let's go ahead and take the position.x and also the position.y on the screen. And then we can go ahead and say that if the list.count, so if the amount of basically classes or channels that have been found is greater than 0, then we want to continue and we want to set our channel to the first object of that list. And we also want to set the text to the channel, basically. And otherwise, we're going to set simply the text to question mark, like that. And of course, we'll need to then reset the timer so that we'll repeat this at every 0.05 seconds. So then let's also make sure to on enable, first of all, disable our image, so we can set this one to false in the beginning. And then as soon as we click somewhere, and this is within our screen space, then we're just gonna enable the image. Oops, like this. Cool. Then back in Unity, let's go to our semantic segmentation game object here, and let's add the semantic query script. And then that's simply gonna fill out all these serialized fields. So the camera manager, the semantic segmentation manager, then we'll have the text, then we'll have our raw image, and finally we're gonna add our material. Alright, so we can test this in editor by using Playback. For Playback, we'll need to go into our Lightship settings, and then we can first of all enable Playback. And I do have a few Playback examples that you guys can use and download. They are in the link in the video description. And it basically allows us to kind of play a video feed inside of the editor to test out our AI application. I also got a whole video on that if you're interested. And so let's make sure that some kind of playback is being selected here. I got my garage horizontal still example here. And then let's close the window and let's hit play. All right, so then let's just click on the screen and we can see that it automatically gets overlaid with this, well, this red texture that we created, and it will also basically state the semantic channel here. Let's try to click somewhere else. So it doesn't know what that is, but it can detect that this is foliage, so it's a bit hard to read here, but you can test it out at different examples. And now we could also potentially go ahead and build this one to our phone and just test it out outside. If you want to know what channels are there at all, we can go to the Lightship documentation, again, link in the video description, see all the channels over here, and then there are also some experimental channels that we can use if we want. So let's imagine now we wanted to build a game where you need to gather resources, let's say wood and maybe some kind of water, or you could even use the sky, and we wanted the player to point their phones at some actual trees or go to some actual water place to gather these resources. So how could we potentially do that? So for that we would need some kind of assets, of course, and in this case I actually went to FreePack and I just entered something like cloud or water drop, for example, and just downloaded a few icons here. So I have some links in the video description. But for example, this cloud here, you can go ahead and remove the background automatically. And once that's done, download it as a PNG. You can download up to 3 icons, I think, per day if you're not logged in. But if you're logged in, you can, I think, do 10. So this will be great just for testing purposes, of course. And so let's go ahead and import those assets. So let's create a new folder. Let's call the folder sprites, like this. Let's reveal in Finder or in Explorer and make sure to open the folder. And then let's make sure to drag all of our assets in here. I think this one is a stone. Yep. So let's also rename this one. And so now we have a few assets here that we can work with. So then in our sprites folder, let's click on those and let's set a texture type to sprite 2D. Make sure that the sprite mode is single. Click apply. So then next up, let's create a new folder and let's call this one prefabs. And for that, let's go to our canvas, right click, create empty. And let's call this one, for example, foliage tree prefab. So the idea is that if we see foliage, so some kind of nature in our scene, then we'll just spawn the tree icon. And let's go into our scene view here. And let's for a second disable the raw image so that we can see what we're doing. And here let's go ahead and right click UI, and then let's create another raw image and drag in the branch here. So then let's give this a bit more width like this. And let's make sure it's also centered. And then let's also go ahead, right click and create a new text. And let's just say something like +1. So for example, if you'd click on the tree, you'll gain +1 as a wood resource, for example. So then let's just create a prefab here. And then once the prefab has been created, you can of course simply duplicate it. And then you can, for example, create a prefab for the ground, for the sky, and for water, let's say. And now we have our prefabs ready. So let's go ahead and then manipulate our semantic query script so that will spawn these prefabs depending on what channel we are actually tapping on. So for that, let's begin by creating a new struct down here. So let's make this one public struct. Let's call this channel to object, like that. And then let's go ahead and make this one system.serializable, like that. And let's go ahead and add 2 variables. So we have once a string and another one as a game object. And let's call this one simply game object. And so now we can actually go ahead and pair up a channel with a game object that could be spawned. So for that, let's create a new list up here and let's fill this one with the channel to objects. And let's simply call this one channel to objects like this. And we'll also want to create a new serialized field. And let's call this one, so let's make this one a transform, and let's call this one spawn object parent, like this. Awesome. So then let's go down here to our update method. And then down here in the check whether the list is greater, so the count of the list is greater than 0. Let's create a new for each loop. And let's go through the channel to objects. And then let's check whether the channel to object, if the channel is equal to the current channel that we have here. So we'll go through our list and check whether, one of these objects correspond to our current semantic channel. And if so, then we could just say, let's create a debug log and let's say the channel, and let's make a $sign here. So the channel with the name channel has been detected and will spawn an object like this. And then let's simply go ahead and create a new game object. Let's call this new object and let's instantiate the channel to object and the game object. And the position is going to be the position that we clicked. and there will be a quaternion identity as the rotation, and then the parent is going to be our parent object. So spawn object parent over here, like this. And then we could, so for example, go ahead and say we want to destroy this new object after 3 seconds, so that it won't stick there forever. And one more thing that I just saw is, of course, we'll need to make this public here, otherwise we can't edit it. Then back in the editor, let's first of all set the canvas as a spawn object parent. And now we can create some new channel to object objects. So then let's go ahead and create a few. And let's simply drag in then the tree prefab, the ground prefab, and for example the sky one. And so now we need to fill in the channels. For that I'll go into the Lightship documentation and I'll make sure that I'll write everything correctly. So we have the ground, then there's foliage, and finally there's sky, and I think it's just, yeah, so it's written like this very easily, but of course we don't want to make mistakes here, so better copy it. So now we got all the channels. Let's also make sure to re-enable our raw image here, like this. And then let's click play to test. Alright, so now if we click just somewhere on the ground, we can see that yes, our icons are popping up. If we click somewhere else, nothing is happening. And if we would now click on the foliage here, you can see that it's actually also spawning those trees here, but we can even see it better and test it better when building to the device. So now if you go ahead and build it to your phone, then we can test it outside and see if things are working as expected. Alright, and here we can see that things are working out well. So this is how semantic segmentation works within Lightship. Alright, but that's it for this video. So I hope it was useful for you guys. If you have any kind of questions or want to discuss anything, then please feel free to write a comment below. But until then, thanks a lot for watching and see you next time.